Hi everyone, this is Digitalk with Bimulus. The purpose of this podcast is to raise built environment digitalization awareness amongst industry, showcase Singapore's efforts on built environment digitalization such as BIM, IDD, and IPD, and look at digitalization worldview through the lens of Singapore. Every month of the last Friday, we'll be inviting guests to discuss the latest BIM trends happening in the world. We look forward to you following our podcast. Thank you. Okay, hi everyone. Today we'll be discussing on Blender and BlenderBIM, but before we begin, we would like to introduce our guest today, Dion Molt. He is an architect and also a software developer passionate about open source. So you'll see him a lot on LinkedIn, and he posts a lot of information on open source. He's also the main developer of BlenderBIM add-on. You can actually download from blenderbim.org, and it's a wonderful add-on that you can use. And it has data-rich open BIM features and capabilities with Blender itself. Afternoon to you, Dion. Could you briefly introduce yourself to everyone?
Hey everyone. So as you've said, my name is Dion Molt. I have worked in an architectural. I have an architectural training, and I've worked in the industry for quite a few years now. I'm currently working for Lend-Lease, doing work across a number of disciplines, across construction, cost planning, as well as dealing with many of the disciplines involved in a job. I've been involved a lot with open source for many years. Projects you might have heard of like Gentoo Linux, KDE, Radiance for light simulation, OpenStreetMaps for GIS, and more recently we've been doing a lot of work with Blender and the BlenderBIM add-on and the software which powers it underneath, IFC OpenShell.
Okay, great. Could you explain to our audience what is Blender and BlenderBIM? And could you also talk a bit on the features and what they're used for? Like for example, is BlenderBIM a native authoring software that's of a open data standards kind of IFC feature?
Yeah, absolutely. So the BlenderBIM add-on is actually, well, an add-on to the software of Blender. And Blender is best described as a 3D content creation platform. And you can imagine of it as the tools you might need to create a movie or an animation or do any sorts of high quality 3D artwork. So that includes modeling, sculpting, rendering, texturing, rigging, animating, compositing, lighting, all of those types of workflows that you would be involved with if you had a career in the CG industries and the VFX industries, or I guess something a bit closer to home, the ArchViz industries, or doing game design and so on. So similar equivalent proprietary software might be things like 3ds Max or Maya. And Blender is a well-mature software for achieving these things, and it's being used sporadically in the AEC industry through a variety of use cases, one of which is architectural visualization. And what the BlenderBIM add-on does is it turns Blender from software that is just used for creating geometry and pretty graphics and animations into software that understands our built environment. And it does that by implementing the ISO standard for BIM. And BIM, as you know, building information modeling, is a way for computers to understand our digital built environment. So how does a computer understand what a wall is, or that a chair can be located in a space, and that space may be on a story of a building, or even what a building is, or that a space might be connected to another space and have an energy space boundary used for energy analysis, or that the chair has a material and the material has a carbon count associated with it. So how does a computer understand all of these relationships? And the answer is that we have an ISO standard which describes a schema that the entire industry can use of how to describe these relationships. And you can think of it as a huge database that describes our built environment. And for those of you familiar with databases, there are many different types of databases. I would say this one is best described as a graph database. There are many nodes of objects, like a window or a door, or a cost item in a cost schedule, or a task on a construction site, and they would have relationships. So for example, the wall would have a relationship to a quantity takeoff, which would have a volume, which have a relationship to a cost item, which has a relationship to a productivity rate, or a labor hire rate, which has a relationship to another node, which is a task, which has a relationship to a duration on a schedule. And all of these relationships are highly parametric and interrelated, as is the nature of our industry. Our industry goes across many fields. I've just described a few over there. And what the BlenderBIM add-on does is it implements this rich digital language that's standardized by ISO, known as IFC, and lets you work with it natively. From day one, you're immediately creating rich semantic parametric IFC information to describe your design, your building, your built environment, whatever it may be. And this, from day one, is standardized. So when somebody says, what's the fire rating of a wall? There's one location where it should always be, and it is always there because it's standardized by ISO. If somebody says, and it's cross-platform from day one as well, if somebody says, let's do a cost takeoff, or let's do a 4D simulation of it, there's no import or export. You can do it directly in that one shared database. And it turns Blender into one interface that lets you interact with this extremely rich database. Sorry, that was a very long description. I hope it made some sense.
Yeah, it definitely makes sense for our audience. Just to introduce what IFC is all about. Basically IFC, you can also go to the Building Smart International website to understand a bit about the schemas and its relationship between the different BIM elements as well. So, since we are on the topic of open source, I would suppose that Blender and BlenderBIM can be downloaded, very easily. Could you show our audience where exactly this can be downloaded from?
Absolutely. Let me just share my screen. Okay. Can you see my screen?
Yep. Showing up.
Okay, so I'm just showing you the blender.org website. So as mentioned before, both Blender and the BlenderBIM add-on are open source software, which means that it is completely transparent in how it works and gives you a huge amount of freedom in how you can use it. Rather than having licenses that restrict how you use it, it has legal licenses that give you freedom to use it in a lot of creative ways. So you can go and edit it, or if you have a developer know-how, or extend it or redistribute it and so on. So this is the Blender website, which you can go and download Blender, and then the BlenderBIM add-on website, which is blenderbim.org. And it's pretty simple. You can see some examples of what it can do over here. I've just talked about authoring IFC models, but you can see how it goes across a number of disciplines. You just press this bright button over here, pick your platform, and yes, it works on every platform. Blender actually can work on an Android phone if you want, so you can edit BIM models on your phone if you were feeling brave, and just press the download button. And there is an installation guide which gives you step-by-step instructions. Download this, download that, press install, and then you're good to go. And then for those who are curious, it goes into details of where is it installed, updating, installation, FAQ, and then straight into a tutorial on how to explore an IFC model and start using the software.
Great. Just a bit for our audience as well. The instructions is very clear and straightforward. It's quite easy to download and install. Once you have it installed on your laptop or your desktop, you're good to go and start exploring on how to work with an ILC model. Since we are also on the topic of IFC, does this mean that there's zero IFC data loss during the the import and the export? Could you explain a bit how this is so?
Yeah, absolutely. So I guess the traditional way that many people use IFC are what we call translated OpenBIM, in that you, and I think there's a little description of that somewhere in here. Let's see if I can find it. Yeah, so a traditional OpenBIM basically takes some sort of proprietary app, such as Revit is a very famous one, and another proprietary app like ArchiCAD or CostX or Microsoft Project or Oracle Primavera, P6. There's so many of these proprietary systems, and they all host a bit of the information that you're interested in your building. And they all host it in a different way. They all have their different apps speaking their own proprietary language. And then you press an import or an export button, and you can think of that as translating from one language to another. And there's a lot of information lost in that translation because the two languages are not equal. It's simple as that. And that's why when many people try to collaborate with IFC, there's a lot of pain involved because they lose a lot of information. And very often, because of that information loss, we don't trust it. We say, this is your native application. This is the wording we like to use. And we say, this is just a reference IFC. But if you ever want to see how things actually work, you have to go straight to the proprietary database. And we don't think that this is a very satisfying way of working, and it doesn't have to be this way. The only reason it is this way is because you are using a proprietary application. If instead you decided to use OpenBIM natively, that means that you could directly work in IFC. And this flowchart is not very evocative. I'd like to simply demonstrate that to you. So I'm going to just launch up Blender here. So here you can see a completely blank scene. And what I'm going to do is that I'm now going to create a blank IFC project. So I'm going to go down here. I'm going to make my screen a little bit larger, just so it's a bit easier to see. And I'm going to load up a demo library just to make things a little bit faster. I'm going to press Create Project. And you can see I have just created an IFC project, and just as a convenient default, it's created a site, a building, and a single story within that building. This is an empty IFC. There's no objects in there, except there are no physical elements in there, but there is a spatial structure, and there are a list of types. You can think of that as a list of modules or blocks or families if you use the Revit language. But in IFC, it's known as types. And you can see that I haven't imported an IFC. I've just created it anew. And that's because the BlenderBIM add-on speaks IFC natively. It's the same way as you would create a Revit file. You don't lose any data in Revit because you're working with Revit, the Revit data schema by Autodesk natively in an Autodesk tool. So it's no different. Here you can work with IFC natively in a native IFC tool. So I can go in, let's say I pick a wall here, and let's pick a 300 thick wall, and I can go and add a wall. So I've just created a wall, and this is already an IFC wall. I haven't exported an IFC wall. It just is an IFC wall by nature, in the same way that you would draw a wall in ArchiCAD, or you would draw a beam in Tekla. It just is. So there's the concept of importing or exporting doesn't exist at all. You would just save and load from an IFC database or IFC file, just as you would do natively. So does that make some sense? It's already an IFC wall. It already has a global ID. It has a type. It knows it's contained in a story. It knows it has a parametric layer definition of how many layers it had. In this case, it's just got one material layer of an unknown material. I can go and continue editing this wall. I can go and extend it. I can go and add another wall to it. Go draw a little there. I can extend it to there. Go these two. Trim that. So, and these walls are parametric and intelligent. They know that they have connections to various things. So, for example, it knows that it has a parametric connection at its start and its end. So if I drag that wall and go over here, it automatically updates because it understands that. If I change the wall type, so if I create a smaller wall over here, let's trim that wall over here. It's already an IFC, so it's not possible to lose data because it understands IFC natively. Create a few doors, and maybe what I'll do here is let's just save that project, and we'll create a drawing at our story. I'll zoom in a little bit. We're pretty far. And there you have it. Maybe we'll add a couple of windows over there. And there you go. So even the concept of a drawing is an IFC itself. IFC supports drawings and documents. So you can store an associated document, sheets, for example, schedules, associated spreadsheets, for example. It supports annotations, different symbols for plan views, for example. All of that can be parametrically supported in IFC. So let's just go and create our beautiful, simple drawing.
Oh, wow, it can be exported as a SVG file as well.
Absolutely, and in fact, you can also put it into DXF if you really, if you want to. And this is vector, by the way, so you can see it's all vector output, and it's to scale as well. So I think you can set your scale. It's just like any other BIM software, right? You can set your drawing scale. You can set custom scales. You can put it on a sheet. I can go and take a sheet over here, and I can put my drawing on it. And I have my drawing. I have title blocks and templates as well. Obviously, I can put a revision and all the rest of it.
Okay. Oh, that's a fantastic capability of this Blender. It allows you to export it as a vector file as well to do your documentation. So could I safely assume that the Blender is also a authoring software as well, given that you can model it and you can do documentation as well?
Absolutely. Well, the BlenderBIM add-on turns it into a complete BIM authoring package. You can deliver a project end to end. At the moment, we are still in an alpha status, so I wouldn't recommend it unless you are a very experienced power user at the moment. But as you can see, this is where we're headed to, so that you can deliver a project from beginning to end, not just your drawings, not just simple walls like this, but everything, your cost plans, your Gantt charts, your carbon takeoffs, your energy models, your light simulations, your structural analysis, your MEP systems and system connectivity calculations. You can do all of that end to end in pure native IFC, no import, no export, 100% free software that everybody can see how it's built and tailor it to their own workflows.
Yeah, there's a few advantages that I see if I were to use Blender to help me to model a project, because if I were to do it in native software like Autodesk Revit or in ArchiCAD, when you try to export it, it takes a bit of time to wait for the thing to be exported. So if you can start off the modeling in the IFC environment like Blender, it definitely saves a lot of time for you to do the exporting time, and it's twice as fast as well, and no information lost when you try to export, because you start off with IFC modeling So that's, I think Blender has, has truly a wonderful thing to work with in this case. Would you agree what I've just mentioned?
Absolutely. I think many people have only ever used IFC in a very superficial sense, almost like the vendors keep on describing it like a PDF, which is extremely incorrect. as you can see here, this is the opposite of a PDF. This is a really rich environment. And just now you saw me save the model, and there was no time at all in saving it, because I'll just save it again, right? I press it and it's done. It's instant. There's no export required. There's no translation. There's no data loss. It already is IFC. You're just marking it as a snapshot in time.
Yeah, so and it's quick, and I can see that now. But I looked at the some of the properties. It says IFC schema is at IFC4. Could you just change it to IFC3? 2x3. If you want to, is it possible as well?
If you've already started with an IFC4 model, I don't have a one button. There isn't a one button press to change its version. You can do it. It takes a few buttons to do it. But in general, you would think twice about downgrading, because you've just described downgrading. Upgrading, no problem. Go ahead, do it, and that's a one button press. So for example, if I started a brand new project, I could just as well pick IFC2x3 or IFC4x3. So if I could pick IFC2x3, I could do the same thing, or this time let's just create a random object over here, and let's say this object is, why not? We'll call it a wall, a very funny shaped wall. Maybe this is a postmodern building. And we'll just save that over here, and we'll call it test. Right, so that's done. And you could upgrade this to IFC4. So for example, if I went in my test, I can press this button, and there we go. We now have an IFC4 version of it, and there you have it. It's now IFC4. Now, I would hesitate slightly before encouraging anyone to downgrade. It is technically possible, but there are a few maturity issues with it, and also there's very few reasons why you'd actually want to do so in the first place.
That's true. I was just asking.
Just curious, maybe.
So, you mentioned that if you are a power user, you definitely can use Blender to help you to model a project from scratch. But if, let's say, if my workflow is from a native authoring software, like for example Revit, and I export it to IFC and I bring it in here, and if I wish to do partial editing of the IFC model, is it possible as well? In the event that there's something that I just want to have a quick edit of that particular element because I forgot to do it in the authoring software, as the exporting will take a lot of time. If I re-export it, is that possible with the model?
Yeah, it's definitely possible. I think there are a few things to understand though before you do that. So when we say edit a model, there are a few ways to look at editing. So if I go and let's just say let's open up a model here. Sorry, I should have had some test models ready to go. I don't. So we'll okay. So maybe this model here. So this one comes from ArchiCAD. It doesn't really matter what it comes from. So you can edit relationships and properties and non-geometric information relatively safely, I'd say. And the reason I say that is because the data that comes from proprietary tools that are non-geometric are generally not too bad. The geometric data that comes from these software sometimes have problems with them, which restrict the way you can go and edit them.
Oh.
So For example, this is a typical example of an issue you might find. So this space is a prismatic cube. This is like a room, I guess. Now,
Yeah.
obviously, the room isn't meant to be like this, right? The room is meant to be clipped and so on. And so editing the room geometry may be a complex task. And I'll go over why that is in a moment. If I just want to change some of the data in here, that's easy. I can just go and press this and change it to whatever I wanted and save it. That's it. So if I want to add new properties, remove properties, if I want to change materials, if I wanted to aggregate it or move it in a different, if I want to move it from level 3 to level 2, that's easy, no problem. But if I wanted to change its geometry, you should always think twice. The first is because you need to see what type of geometry is being used. So in this case, this is, this is an excellent example because I would say that this is actually invalid geometry. I have to double check this before, but I'm pretty sure that this is already invalid. Oh, sorry, what is this? This is actually viewing the box view of it. Oh, that's interesting. I'll have to take a closer look at that. Let me find a simpler example here. Okay, so this wall, for example, the wall is actually defined as a BREP, which is fairly, I would say, not the most appropriate way to define this wall. This wall is a simple prismatic wall. And for 90% of walls out there in our industry, you can define a wall simply by an axis line and a thickness, and then you have a height, and that creates your wall. And this wall is no different, and that would be a solid wall geometry. And there are many types of geometry in our industry. You might have heard of meshes, and you might have heard of NURBS, for example. There are many different types of geometry that are used, and the far most common geometry used in our industry are solids, which are things like simple extrusions. Whereas this wall is represented using a BREP, which means that I would be editing it in this form. And you can see that this wall actually has this weird slice in it. And that's just the way that ArchiCAD has given it to you. So in this case, it's no problem for me if I want to edit this wall. If I wanted to go and stretch out that wall in a particular direction, no problem. I'm done. I've just updated that BREP. It's upgraded to a compatible type of a tessellation for IFC4, and I've just edited that wall. You can see that was very simple to do. However, it may not always be that simple. If they have used an incorrect geometry type, you may need to convert from one geometry type to another. So you might need to convert an extrusion to a mesh type of geometry, or vice versa. For example, if you have a whole bunch of structural steel beams, which are best described as extrusions, because that's how beams work, that's how they're manufactured, that's how they're installed. But if they're described as a mesh, you may want to convert them into parametric extrusions so that you can easily edit things like their web thickness or their flange thickness and so on. So unfortunately, I can't give a full explanation here. I should have come prepared with a list of examples. But yeah, all these walls are coming out as mesh type objects. So I would have to edit them. You can see that in order to edit them, I would actually have to select that, then move each individual vertex, which means that I could actually technically move the wall like this. And maybe that's what you want. Maybe that's how you want to edit the wall. Maybe that's not what you want. I don't know. It's all very case by case, and it's hard to give these kind of generic answers to it. So let's just create some crazy design here.
Oh, okay. Okay, I didn't know that through if it's exported with the BREP condition, you can actually still manipulate the form and the extrusion of the wall, and it's such an easy and I think this is quite wonderful as a software that you can still manipulate the model for partial editing in this case. talking about editing, when you export, often you have your IC, your classification together with your, PSET and whatever metadata that comes with it. So if let's say if I'm doing a fresh new project and there's a particular wall that sometimes IFC classification doesn't capture certain predefined object that I want to name it in certain way. Can I still do user defined manipulation with the IFC here? Say for example.
Absolutely. So, and basically this supports everything that IFC supports. So if IFC supports it, it's almost certain that you can do it here. And if you can't do it, maybe we're just missing a button for it, but there's nothing stopping you. So for example, let's select all walls of this type. So I've just got all the walls of the same type. And this wall, you can actually see if I has no predefined type associated with it, and that's not very good. So if I go and bring out all of my types, and if I go to my type, so now I'm on my type, you can see that the predefined type is not defined. And of course, I can go and select from one of the presets that IC provides. And you can see I can actually hover over them, and then it will actually describe what those things are straight from the IC documentation. So you don't need to be an IC expert to use this. Well, sort of, you kind of still do at the moment, but we're making it easier and easier. So let's say if it is one of these, you just say, okay, you are now a partitioning wall, and that's great. Now you can see that all of these walls have inherited that type, that predefined type as partitioning. And then you just told me, what if you wanted to provide a user-defined one? No problem, you can do that as well. You go to the type and you just say, you are now, where's user-defined? There it is. And I don't know what type of fancy wall. Call it a fancy wall. And now everything is a fancy wall.
Okay. Oh, it's really easy to do use to amend it to user defined. Because if you're gonna do it in the authoring software, there's so many things that you need to set it up before you can actually make it as a user defined. This really simplify the workflow entirely just by clicking and just edit, and then that's it. That's your user defined name. It's fantastic.
Correct. Because it's native IFC. It shouldn't be difficult. It's just an attribute.
Yeah. And does IFC, I think you mentioned earlier on that about scheduling, about if even if you want to do construction sequencing, does it work with other types of software since it's IFC? Does it do like things like costing? Does it does Blender does scheduling? Does it also do clash detection?
Yep.
And sometimes design can get pretty organic, and especially with BIM capabilities now, you have computational design software as well. Is it able to do visual programming and come up with complex forms, just like Dynamo or like Grasshopper and Rhino? Is that possible?
Absolutely. In fact, I would say that the forms that it comes with are many times over more complex than what people are producing in Dynamo and Rhino. You have to understand that Blender is a CG tool. So forget Blender BIM for a moment. The underlying modeling tool here is Blender. And I mean, you just watch a typical movie. You've seen the worlds that they create from this software, right? It's incredible, the details. I mean, for example, that grass, it's generated and placed and scattered on an environment. Those mountains are maybe sculptor generated. Who knows? Maybe all the trees are generated. I mean, you wouldn't do that in tools like Grasshopper or
Dynamo.
or Dynamo. I mean, and you'd and I mean, I'll have to think of a best place to exhibit these types of things that Blender can do. And a lot of that uses their own sort of visual scripting paradigm. It's a different way of thinking, compared to people who have been brought up with Rhino, for example, and Dynamo. So you have to switch your mindset a little bit. But if you get around to it, you can get some examples. So one of it is called Blender Geometry Node. Sorry, I'm answering your questions backwards. I will get back to the costing and scheduling bit. So let's just see. Here's, this one looks probably a little bit familiar. You can see similar things that you might do in well, maybe not this. Like, I don't know if you generate that in that's a pretty, yeah. Well, this is one example, and you can see the nodes being used to generate things.
Yeah.
Another one.
I suppose the nodes works in a similar way, like the way how Unreal Engine does their rendering part, where it's a connection of nodes that render the model in a certain way, and it behaves in a certain way, like for the lighting. So I guess, yeah, the concept is still the same. It's still with wires and with nodes, and then it's just wrapping your head around with the different script that comes with the nodes. Is my assumption correct? In the interpretation of what you're trying to describe?
Well, you're absolutely correct that node-based interfaces are not new. They're used in all sorts of places, and very commonly they're used in materials and compositing. So, for example, if I were to add a material, like not a simple, this is brown material, but a more complex material, I would create nodes for that. I would go and split my interface, and I would go into the shader editor. In this case, I have a very simple set of nodes, but I would go and add some more. Maybe one for an image texture, one for some texture coordinates, and so on. And I would go start joining in these nodes together. That's where the similarity ends, I think. I mean, nodes are a fairly generic interface, in my opinion. They can be used for all sorts of things. I think that the main difference lies in that how Dynamo and Grasshopper look at their data is different from the way that the CG industry looks at their data, because the paradigms used in the CG industry are very different. Very often in the CG industry, you use meshes. And in Rhino, for example, you rarely work with meshes. You work with curves and surfaces, for example, and points directly. Whereas over here, if you wanted to, in IFC's Furjok, for example, you would work with a soup, I think is the best way to describe it, a soup of vertices, coordinates, and indices and edge indices. Like it's hard to describe unless you've actually worked with meshes. It's a totally different way of thinking. And so the way you wire up your nodes or you think about your nodes also changes. And then that's Furjok. And then geometry nodes also has a different way of looking at things as well. So there are a few paradigms out there. And I think as far as IFC is concerned and BIM, geometry is not essential to a BIM model. Many people think of a BIM model as, I have a 3D building, that's my BIM model, and I export my 3D building and it has some properties. But that's a very superficial understanding, because the 3D geometry is no different to a property. The 3D geometry doesn't need to actually exist at all. What's important in BIM is that you have a wall. Whether that wall is a rectangle, a mesh, a solid, an extrusion generated via nodes or not generated by nodes is secondary to the fact that you have a wall. And so you can hook up a variety of, I guess you call them geometry generators. And it doesn't matter what you use. At the end of the day, you can always plug it in as a geometry to be connected to an IFC object.
Yeah. You are right. Basically, when you extract it as an IFC model, it's actually a textual file. Unless we want to see it visually in the 3D environment. Basically, it just if you export an IC model using Python scripting, it just gives you a bunch of text, right? In Notepad, for example. But if you change the Notepad extension to IFC, immediately it becomes a model that can be visualized in the authoring software. So in a way, I think I do agree that the geometry is secondary to the information that that, for example, a wall behaves like a wall, right? So I do agree with your explanation of what when you're trying to extract IFC as an information. Yeah. Now, how about the costing and the clash detection and the scheduling for construction sequencing? Could you explain a bit on that? Is it possible to do that in Blender as well?
Absolutely. So let's go back to our simpler model. And maybe I'll create a slab as well, just so that we have a bit of variation here. So create a slab there, and I'll edit the slab's profile. I'll just snap from there, snap, snap, here, here, and snap that one there. Okay, great. We got a slab. Let's save that. All right, so if I wanted to, I could go and create a schedule. So I would go and, ooh, things have changed. Sorry, I haven't used this part of the software in a while. So I can create a new schedule. I can create a new calendar. I can create a work plan. They can be baseline or planned. And then I can generate a Gantt chart from it. Alternatively, I can go and import from existing software like P6 or Power Project or Microsoft Project. I'm not sure if I have one of those available, but that would be nice because then I could just show you a full Gantt chart already without having to build one up from scratch. So I'm just curious if I have, that looks suspiciously small. I don't think that's one. Let me see. Okay, well, I'll attempt to create one from scratch, but if you've used scheduling software, all of this should be pretty similar. So you create a calendar. So let's say this is 9 to 5 p.m. and this, so there we go. We got our 9 to 5 p.m. calendar. And then we can say we are working from, this recurs every week, Monday to Friday. Let's say we start at 9 a.m., finish at 5 p.m. And that's it. Great. So we have our 9 to 5 calendar. Now we will create our planned work schedule. This is our blank Gantt chart. So we'll go and add our summary task, and then we can add some subtasks. So let's call this our, our work schedule. We can add some subtasks to it. So we can say, I don't know, site establishment. We can add another subtask to it. So let's do it real simple. We'll construct the slabs and we'll construct the walls. And of course, this all has names to do with it. I can go and name things however I'd like to, and then it will detect your naming scheme and it'll continue. I'm just typing it manually over here, but of course it would automatically do that if I needed it to. Copying tasks. There's no dates or anything at the moment. So if I go and let's get some start times, end times, and duration. So this is similar. If you've used scheduling software before, you'd set up your columns. Obviously, you'd have a preset for yourself, your start and date, and you'd have a series of columns that you'd typically, each user would like to sort their task by. And let's say we'll start that here, and this will take 3 weeks, for example. Sorry, I haven't assigned my calendar yet. So we'll have to, of course, assign our calendar. We'll go say that's our 9 to 5 calendar. Great. So you can see how we can specify and it can calculate working days and so on. We can also set relationships as well. So I think maybe that's the button to set relationships. So we can say that this happens as a successor or a predecessor. So we have successors and predecessors, time lags, and so on. And of course, you go and continue. And right now I'm doing pure schedule. Notice I haven't touched the model at all. In theory, though, I can have some quantities come out of here and then start assigning things. So for example, if I go and say set some random dates over there, and I can recalculate the schedule and generate the Gantt chart. Great. So I've got some sort of made up schedule over here, and that's fine. And I can, of course, start assigning my inputs and outputs and my resources to it. So I can so let's select all my slabs. In this case, I have one slab, so I'll just have one slab over there. And then for all my walls, I'll select all my walls. And in fact, I want all the things within the walls as well, my doors and windows. So I've just selected all the decomposed things. That was with a hotkey, by the way. And we'll just add all of those. So great. So now I have assigned the various objects. And sorry, I think I messed up, actually. I think I should have assigned them as outputs, not as inputs to the task. Sorry. Obviously, I don't do a lot of scheduling very often. But you get the idea. I would add them as outputs as well, as outputs, not as inputs. And then I would go and I can create an animation for it or whatever. I'll add them as outputs instead. There we go. That's a bit better. We'll remove that as an output. There's some animation options. I can customize the colors, if I'm demolishing or constructing things, and so on.
Oh, it's basically a full-on, scheduling. It has scheduling capabilities to show the production sequencing together with the modeling as well. So yeah, it's really fantastic. It has so many features. It's almost a one-stop shop kind of software that allows you to manipulate your model from not just modeling but also for construction as well. But can it also do clash detection as well?
Yeah, absolutely. So we have clash detection quality control, I think. There we go. So you can create clash sets. You might want to say mechanical versus structural or something like that. You can set your tolerances. You can add multiple clash sources. So for example, it can come from one IFC file or multiple IFC files. And then you can set include or exclude filters. So if you want to have all of the distribution elements of a mechanical model, obviously this is not a mechanical model, clashing with another model, and we'll just want to include all your columns from this model over there. And then I don't think it will, if I press this, it'll probably be garbage because there aren't. Oh, well, this is, sorry, I misspelled distribution elements. There's no such thing as distribution element. So let's just clash all elements. There we go, and it crashed. so I must have done something wrong, or there is a bug. But there is ability to do a clash detection, which currently obviously has some problems with it. And I think this is a good time to also warn people that what you're seeing here is alpha software. It is work in progress. It is being actively developed. And when I say actively developed, I mean that day by day, there are significant changes. So the version from last week is already pretty old. A whole bunch of fixes and upgrades and new features have been implemented since 1 week ago.
Yeah, and that's the wonderful thing about being open source, right? So the software gets refined almost every day, 365 days. And it gets better and better, and eventually it will resolve all the issues that we face. And I guess the reality is software will often have bugs, and that's why we have patches and all that. looking at what you have here, I see that there's some extension earlier on that I saw that you can actually export it as your Clash as a BCF file. So in other
Correct.
words, am I correct to say that you can actually open it up in a BCF format and then you can do markups from there as well?
Absolutely. And in fact, we also support BCF. I'll just load up our file
Yeah.
before. Uh, you can also load up BCFs directly here. You can create a new BCF project or load a BCF project and do your markups directly in Blender. So we don't just support IFC, we support the ecosystem of open data schemas that exist around BIM, and BCF is one of those. We also support a couple of others.
Yeah. And I saw it in the earlier image in terms of error, I saw also extension with the .py. So is the software built on Python scripting? And if so, could I actually script something in Blender itself and manipulate certain data that I want to extract? Is that possible? Just out of curiosity.
Yeah, absolutely. And in fact, this is what makes it a great educational tool, because most software out there, if you want to teach somebody BIM, you're not really teaching them BIM, you're teaching them how to use a tool. Whereas here, it's fully open, so you can interact with this fully with code. In fact, you can all of the functionality which you see here could have been done in code. And in fact, you don't even need Blender at all. In theory, you can take the entire engine that runs underneath BlenderBIM, called IFC Open Shell. You could plug that into Revit, for example, and turn Revit into a native IFC authoring application. It's actually theoretically possible to do that. And this kind of transparency and openness around exactly how the internals work is a great thing for academics and people trying to really understand how does BIM actually work. So let me show it to you. And by the way, you also asked, is this built in Python? And the answer is some of it is built in Python, not all. So the interface, for example, is built in Python. The geometry processing is built in C++. So different languages have different pros and cons. So you would use the best language for the environment that you're in. So for example, you could actually use this on a website using JavaScript if you wanted. You could use the exact same system, but write in JavaScript language if you're building a web app, for example, and something was important to process client side, you would use JavaScript. So there's a variety of languages used here. The one I will show you right now is Python. So Blender actually comes with an interactive Python shell. So you can type in Python code over here and execute it immediately. You can see I've just printed
Oh,
the text hello.
okay.
So what that means is that you get the full capabilities directly in here live. So I can say, let's get my model. This is the one I've actively loaded in the scene, and you can work with it partially in code, partially visually. And so this is the model object. I can say, get all of my walls. And here you have all of the walls. Let's get a count of all of my walls. You see there's 8 walls, and if I counted my walls visually here, you can see there's 8 objects down there. So you can see they match. I can get a list of all of how many wall types do I have? I've got 4 wall types. I can, for every single wall type, I can go and print out wall type name, and I have wall 50, wall 100, and that matches what you can see here under my wall types catalog. I've got 4 wall types with different thicknesses.
Oh wow, this is really fantastic. It's not only, besides the features of the prior demonstration that you've shown us, you can do scheduling, you can do timeline construction sequencing, you can do modeling, and apart from that, you can also, extract data, just by coding on the site as well. So it's almost a one-stop digital platform that you can do so many things at one go. Wow, this is really fantastic for software like this. to interrogate your model and your BIM as well. So wow, um, wow. Is there
Yeah.
anything that Blender can't do?
It's actually a bit of a running joke. What can't Blender do? But of course, there are plenty of things which Blender can't do, and plenty of things which the BlenderBIM add-on still has yet to implement. So, for example, we still haven't built many tools for parametrically editing MEP type objects. So automatic duct connections and automatic orientation of fittings within duct junctions. We haven't built that yet. We haven't. You can sort of do structural analysis in there, but it requires it's not a I just press and draw a house like I did over here. There's many shortcomings which we are aware of, and but that's okay. We'll just tackle them one at a time until slowly but surely, uh, well, you can do everything.
Yeah.
But
And
I guess that's the benefit of open source, in that if you can't do something, the answer isn't just too bad. Computer says no. Um, you can or if you find somebody with the know-how, can most likely build that capability into it. Kind of like the flexibility that people found when visual node programming allowed them to build their own scripts. This is, of course, the next level. Everything is available to you. I should, by the way, mention here that just because this is often a point of confusion. The BlenderBIM add-on is purely a graphical front end. Underneath, we use IFC OpenShell, which is the engine which you see here, which allows us to interact with IFC. So all of the systems you see here actually have a huge library of functions available to developers to go and build their own systems that they need. So for example, if I go under, we'll go under Python just to make it a bit less technical. You can see there is a huge API in there, and you can see there's utilities and modules. So if I wanted to see what utilities I have, I can see here are element utilities. If I want to get the container of an object and get the material, get a type, get a quantity, if I wanted to interact with it, I can go and in the API. So for example, I would say for costing, I can add a cost item, and it becomes one line of code. It teaches you how to add a cost schedule, how to add a cost item to that schedule, how to add sub items to those cost items. It gives you example code, and you can do this right now. I mean, I could go and copy that over here, and well, I got to import IFC OpenShell. Okay, great. And I now actually have a cost schedule that I just created with code. I could have pressed a button for it, but I didn't need to. I now actually have a cost item, a cost schedule. There it is. There's my unnamed cost schedule that I've just added.
it's almost, the documentation almost behaves like a chat GPT kind of, archival.
Yeah, although now you can probably just ask those AI systems itself.
Yeah. Yeah.
There's a
But
whole bunch of example templates here of how to create buttons and UIs and drop-down lists and gizmos and all this type of fun stuff if you want to build your own extensions. Like if you want to create your own sub panel here with something tailored to your company or workflow, you can do it.
so I can basically also code it in Visual Studio as well, and then just import the code in, and it will still bring in what I need in the Blender environment as well, right?
Absolutely. So you can use any text editor you want. This is just for convenience typing it in here. Blender has a built-in text editor, so I could have equally well typed it in here as a full script, or loaded it from a file. I could go open it from a text file that I already have over here. Or you could just use Visual Studio if you want to, or any text editor of your choice.
Notepad plus plus or whatever.
Exactly. Totally up to you.
Okay. Wow, that's really fantastic. It's if somebody like yourself can become a power user, I think it will save in terms of cost to buy, because if you were to do BIM, full on, you need to buy a BIM software to do modeling. You need to buy a BIM software for clash detection or timeline construction sequencing. Then you need to buy another software for costing. So and would it definitely save a lot of cost, especially for software like that that's open source, and with the capabilities that you have shared. If I'm a power user, it will definitely save a lot of time and cost for me as a BIM user. Yeah. Yeah. Are there any other, future things that you're still working on Blender? I mean, besides having to, like what you've mentioned, that MEP system is still not adaptive yet. Is there any other things that we can look forward to with Blender?
Plenty. It's a infinite list of to-do items. I think there's a reason why there is a monopoly situation in the market around these software, because it is difficult to build this software. It is not easy to build BIM software. There are a lot of things involved. And to an extent, it's actually easier to build isolated BIM software. A lot of the software that we use is isolated. So for example, grand scheme of things in our industry, it plays a very small part. It doesn't do, as you say, the scheduling. It doesn't do the costing. It doesn't do the facility management. It doesn't do the building operations. It doesn't do sustainability. It doesn't do light simulation. It doesn't do ArchViz. There are so many things which it doesn't do. And it will never do. It's never planned to do it that way. And I think this is what we're seeing here is the birth of the next generation of BIM tools, which are designed from day one, where the tools don't just bite off a tiny little portion of it. It's the tool is designed from day one to go across every discipline, like you just saw. Like I could just instantly throw in a cost schedule. It's like nothing. There's no effort required. That will be the next generation of BIM tools, the next layer of intelligence that we have in our models. When our tools can start doing this, when they stop behaving as packaged tools that you buy and achieve a goal, but instead as a tool through which you interact on a bigger BIM database, this IFC database that holds these rich standardized relationships. So there is a no end of task that you'll see us need to do, because when you create a wall in a tool like this, if I ask somebody who's a whiz in Dynamo or Grasshopper to create a wall tool, they could whip it up in a day probably, that can start creating walls. But can that wall be costed, right? Can that wall parametrically be connected to a work schedule? Can that wall calculate its weight or work out material wastage? Can that wall be acting as a neighbor to a space which has thermal properties, which is used in energy analysis, right? All of these things haven't been considered in the wall tool that is built in a day. And so there are very, very smart people who have recognized this as a problem and have been slowly solving it across many, many years in building smart, and have tried to standardize the way that when we say we're making a wall, that wall isn't just a box like you can see here. This is a truly intelligent wall that can work across all the disciplines. And that is an incredible challenge. And we are we have made so much progress, and it's strange because many of the industry is not even aware that this progress is being made. They're still treating their walls as just a means to an end, a means to get a black rectangle on a drawing so that I can, dimension it and submit it to the council. We're making a huge amount of progress to this next level of semantic richness, of meaning in our built environment, which we will need because our buildings are having a bigger impact on the world, that we are unfortunately losing losing a sense of priority over, that we need to pay much more attention to. A lot of us are using tools as a means to an end to just churn out more buildings faster, and that building generators is one thing, but that's not necessarily what the world needs. When you think slowly and carefully about what the world might need, what BIM actually means is the ability to create wise decisions in your designs, the ability to be informed across all the disciplines at day one, not after a 2-week turnaround, a month turnaround with another discipline, but live across all disciplines. Be fully informed on the impact your every decision you make has on everybody else involved, and what that means for our world. So when you put it like that, the tasks are never ending, because our world is a constantly changing environment, and the challenges are always growing, and sometimes I worry that we don't keep up.
Yeah, totally agreed. I think often than not, BIMing is always thought, it's always misunderstood that it's about modeling, but it's more than that, because of the especially with this era that we are in. It's about big data. It's a very big data centric world that we lived in now, and a lot of times the data is being overlooked, in the sense that it helps us make much better informed decision, and especially with the built environment, it has a lot of implications on what we do, in the context of, say, for example, with the environment, and in terms of sustainability. These are some of the things that oftentimes could be overlooked, on the social level, on the economical level, and the worldview level as well. So I do understand where you're coming from. It's great that you have shown us the capabilities of what Blender can do. I'm really amazed that it's really a one-stop shop for almost everything, up to the point that you can even manipulate information just by doing coding on the side as well, with the BIM model, and often interesting conversation. It makes time passes so fast. And Dion, I think we have come to the end of our podcast. I would like to thank you for sharing what Blender and what BlenderBIM can do. Thank you for your time. Thank you so much.
Thank you for your invitation. It was a pleasure to be here and discuss these topics.
Yeah, and on behalf of the audience, we look forward to what Blender and BlenderBIM can do in the future. And hopefully with Spotify we can help, and YouTube we can help broadcast this to everyone, the potential of using this software. Thank you, Dion.
Thank you so much. Have a good day.
Good day. Thank you. Bye.
Thank you. Bye-bye.
Hi everyone, thanks for joining us on the session on Digitalk with Bimulus. We hope you have gained some insights from the episode and hope you could follow us in our next episode again. Thank you and goodbye.